So let's get into some terminology. The first thing is that every time somebody says AI, I cringe a little bit because they almost certainly mean machine learning. Machine learning is a discipline that's essentially statistics, but all of the exciting developments have been machine learning models applied to large data sets. And the although machine learning encompasses probably similar statistics to the ones that you've learned if you've taken a stats class, machine learning statistics are applied to messy data like text or images or video. This was actually my entree to the field. I was trained as a psychologist, and I love and as a psychometrician, I love the big data analyses that psychometricians do with exam data. But that's after the exam is done. Wouldn't it be cool if we could do big data analyses before the exam is done that could help make better exams? And that's what led me to machine learning. Machine learning definitely could address that. The other thing about machine learning is that it generally shuns theory and focuses on predictive accuracy of models. So there's a strong focus on models and modeling and the predictive accuracy of those models or the classification accuracy of those models. And here are some key terms within that space. So supervised learning models are ones that predict or classify. If you've ever used regression, that's a supervised learning technique because you have your X variables and you're predicting a Y variable. That's the nature of all supervised learning models. Unsupervised learning models look for patterns. And some common examples that you might have heard of or have used include factor analysis or cluster analysis. And you'll notice that neural networks fit into both of those categories. We're going to talk a lot about neural networks today. Feature engineering is a consequence of using messy data. So when psychometricians look at data, we've curated those data sets so they're all very neat. Every item was administered to a person, or we have procedures if the item wasn't. But when you look at like essays, that data is not nearly so neat. It's messy or unstructured. And so feature engineering is a process where a human analyst applies her subject matter expertise to create reliable measures out of that messy data. And that's an important thing. And the best example I have of that is Project Essay Grade, which was a project that I think started in the 60s to grade essays. And they didn't have some of the tools that we have available today. So they would do things like they would count the number of words, count the number of sentences, count the average sentence per word, calculate the reading level of the words, and they would develop all these measures that their expertise told them was related to the quality of the essay. Then they'd have a nice, neat data set of those measures that they would put into a multiple regression equation to predict the quality of the essay. So that's feature engineering. And if you've heard about deep learning, the cool thing about deep learning is you take a complex machine learning model like a neural network and you give it a mountain of data, and these models simultaneously automatically perform feature engineering using unsupervised learning, and then they use those features to predict or classify. And the best example I have of that is facial recognition. We train facial recognition software, and we don't have to tell it. We don't have to pre-process the data to tell it, to put a circle around a person's face and to identify, annotate the eyes. The software knows about those features and probably other features we didn't think about, and it can automatically, tell me whether a picture on my phone is Uncle Joe or not. So that's the best example I have of deep learning. But deep learning is pretty exciting, but it does require very large amounts of data to accomplish that magic. And then one other thing that's quite important in general, maybe a little less so when we start talking about large language models, is cross validation. And so when you're doing supervised learning and you're predicting or classifying, you have one data set that you use to build that model. And in that data set, the model will for sure have high accuracy in predicting or classifying. And it won't apply to a fresh sample. So cross validation is some methodology for assessing the accuracy in a fresh sample so that you get an accurate estimate. And natural language processing is another term, and it refers to ways that AI can do useful things with text or speech input. And I wouldn't think about it like reading or listening exactly like a human reads or listens, or at least that's not how NLP has worked in the past. And I would describe NLP as often focused on creating features for machine learning models, for extracting useful pieces of information. Like part of speech tagging is an algorithm for identifying the part of speech, noun, verb, adjective, adverb. If the number of verbs you use or the proportion of sentence with adverbs that were helpful for project essay grade, they could use part of speech tagging to add that piece of information to their regression model. And I wouldn't say that natural language processing is going away, But large language models are really disrupting it. They provide an unprecedented ability to work with language. And natural language processing is used whenever machine learning models need to interact with textual or speech input. So automated scoring, language translation, things like that.